All right, so in the next page here, we are going to outline the steps for graphing a rational function. So you've got your p of x over q of x form and all the different things we can do to get some information about what this function will look like. Some stuff, straightforward, we've done it for plenty of graphs. Finding things like the y-intercept, where you plug 0 into the function. So that'd be plugging 0 into both the numerator and denominator and just seeing what you get. X-intercepts, like we just mentioned on the previous page, are where your numerator is equal to 0. So setting the numerator equal 0 and solving will give you the values of the x-intercepts. Then, as we've also seen in this section, the vertical asymptotes come from the zeros of q of x. So setting q of x equal to 0 and solving and finding any real zeros out of that equation, those will be our vertical asymptotes. Our horizontal asymptote, remember that was the one where we're looking at the lead terms. We're looking at the degrees, comparing them, and then also, if necessary, the lead coefficients to determine if there is a horizontal asymptote. If there is, then looking at the question of does it cross? That was where we set the function equal to the y value that we found for our horizontal asymptote to work through that process to determine if it crosses. Then the sixth step, which I will say I consider somewhat optional, says compute additional points needed to sketch the graph. This is something you can do. You can plug in more x's and see where you get points, and that's fine. But I'm going to tell you that from this information, and specifically, it's not mentioned here, but from multiplicity and understanding multiplicity, we can actually generally get the sketch of our graph just from this information right here. There's some specific examples where you might be lacking information and you may need additional info that points could provide. But other than that, this information will generally allow you to go to step 7, which is drawing the actual, or sketching, I call it, sketching the graph of the rational function. And so there's a couple of things to keep in mind here, things we've mentioned. You do need to make sure when you find all this information up above that the graph you draw follows all those rules, goes through the points and approaches the asymptotes. We want to remember that it might cross the horizontal, as we saw there in the question 5, but it will never cross any of the vertical asymptotes. And then this is just a really quick summary of the idea of multiplicity. The idea that the odd multiplicities of both x-intercepts and vertical asymptotes, that's where we're going to see a change in sign, right? Odd multiplicity of x-intercepts is where it crosses, and odd multiplicities of the vertical asymptotes we just saw, that's where we have the opposite infinities. What's not written here but implied is if you've got even multiplicities at x-intercepts or vertical asymptotes, we know the sign will not change. It's going to bounce off those intercepts or have the same infinity for the asymptotes. And so that's all stuff we'll take into consideration as we try to sketch these graphs.